Hello, welcome to Engineers Mindsets. Now, in this class, I'm going to show you how to determine centroids of composite sections. Okay, first of all, what is a composite section? A composite section is simply a section that involves more than one shape combined together. For instance, I can see on the board, I have what is simply what L shape. So this is actually a composite section because we have more than one shape. If I decide to segment here now, if I decide to segment this point, I will see that I've obtained what two different rectangles joined together. So I can call this rectangle 1, I can call this rectangle 2. So it becomes two rectangles or two components joined together. So this is called a composite section. Okay, now I want to find the centroid of this section. Now, the very first thing I will do to find the center of the section, first of all, which is splitting this section into their respective shapes or segments, which I've done here. So I will now employ a tabular method that makes it very easier. So on the tabular method, I will include the components. Okay, I will employ a tabular method called this components. Now this represents what how many components you have in the shape. In this case, we have just two components making up the composite bar, the first component or the first rectangle, and then the second rectangle too. So simply we have here to be 1, which is the first rectangle, okay, and then we have the second rectangle 2. Okay, so we have this. Now, after obtaining, splitting this into 2, the next thing to do is simply what? Find the area of each of these components. So I will make a table for the area. So simply area. And please take note, you don't need to convert the units to meters. You don't need to convert the unit to meters. Just keep it as what? Millimeters and work with them. So I have to find the area of each of these components. Now for the first component, the depth is given as what? 50 millimeter, and the width is given as 20 millimeter. So which means the area of this component is simply what? Width times depth, which is 20 by 50, and that simply gives us 1000 millimeter. So the area of the first component simply becomes 1000 millimeter. So you keep it at that. Next is to find the area of the second component. This is the second component now. The depth here is 10 and the width is 40. So the area of this component is simply 40 by 10, and 40 times 10 simply gives us 400 in millimeter squared. So we simply have the area of the second segment to be 400. So after obtaining these areas, next thing to do is to what? Sum the area up. So we simply have summation of what? The area. Simply add all the areas together. So if I add 1000 to 400, I will simply have 1400 millimeter 4. So this becomes the summation of the entire area. So this is the very first two things to do. Now, after obtaining the areas of these components, the next thing to do is to find what is called centroidal distance. Now, we have centroidal distance y, we also have centroidal distance x. So I'm going to explain that for you guys. So we'll start with centroid distance x, okay, centroid distance s, centroid distance x. Okay, so we have to find the centroid distance for each of the what components. We have centroid distance x and centroid distance y for each of the components. All right, so now what is centroid distance x? Remember in 2D or in your graph system, we know that if I have something like this, particles that point upwards here represent my what? Y direction, and particles that point here simply represent my x. So this is my x direction and this is my y direction. Same thing happens here. Okay, this line here, this width here for this man represents what? The x component or x direction. Okay, represent the x direction for what? This particular component 1. Same thing happens here. This base here also represents what? The x direction. Okay, represent the x component or x direction for what? This other component 2. Meanwhile, this height, okay, this height here represents the y direction. So simply call that y. Okay, that represents the y direction for what? This component. Meanwhile, this height here, okay, meanwhile this height here, okay, simply y. represent the y direction for what? This component. So which means if I want to find my centroid distance x, it means I'm going to be bisecting what? The x-axis of each of what? These components. Now, the centroid distance are always brought to a reference line. Whenever we are done bisecting, we bring them down to a reference line. What is this reference line? The reference point is that point which the two components actually what? Come completely what? To ground level. Okay, just say come completely to ground level. All right, so at this point, now these two components, this and this actually comes completely to ground level between what? E and simply D. This is point D. Okay, so this is the reference line now for this. So which means I'm going to send everything I'm doing from beginning down to the reference line. So if I have more than one component, let's say I have an I shape which involves three different components, I'm going to take everything down, all the centroidal distance down to the reference line. The reference line is E and D, or simply what? X, X, which is the horizontal line for what? This other segment, the second segment. All right. Now, I want to find central distance x. I've told you that since here simply means x, it also means this is the x-axis for what? This particular what? Component. And central distance simply means bisect the x into two. So I want to find the central distance of this man, or the first shape. I will simply what? Bisect the first shape into two, and this is the x. So if this is x line for what? The first segment, then I'm dividing this x line into two. That is simply what? Dividing distance from this point to this point into two, which is 20 millimeters. So I'm dividing the 20 millimeters into two. That gives me what? The centroid distance. But it doesn't end. Now, if I draw a meeting point, let's say I draw this over here. It might not be accurate, please forgive me. Okay, and I have this over here. All right, so if I bisect this man now into two, I simply have 20 divides by 2. Okay, so that gives me here 20 all over 2. But it doesn't end there. I said if you find the central distance, you must take everything down to the reference line. So this same thing here is same as saying splitting this point into two, which is see from here to here, because this represents the x-axis for what? The first segment. So if I split here into two, it also give me what? That 20 divided by 2. But this is the reference line. ED is the reference line. So I have to come down to the reference line, which is bringing this man down from this point to the reference line. Okay, so after splitting, you take everything down to the reference line. The height it takes this first segment to get to the reference line is simply what? Distance from this point to this point, which is simply what? 10 millimeters. So I will simply add this 10 millimeters to the central distance of what? X. That gives us the total central distance of the first figure. So I will simply add 10 millimeters to the central distance of what? The first figure, which I've obtained. That's 20 divided by 2. So I simply have there plus 10. Okay, that is the height it takes this shape now after cutting through the centroid to get to what? This reference line. All right, so I'm going to wipe this off. Okay, so if I do this, I'm going to have equal to, of course, 20 divided by 2 is 10. 10 plus 10 is 20. So I simply have that to be what? 20 millimeters. I have this. The next is also to find the central distance x for the second segment. Remember the second segment, I said the x line for the second segment simply remains what? Here. Why this is the y line for the second segment. So if this is the x line for the second segment, it means I have to simply what? Let's say I draw my centroidal whatnot, okay? And I have this. So it means I have to cut through what? The x line, that's central distance x for the what? Second segment. So if I cut through the x line, it means I'm dividing what? The value of the x by 2. Remember the width represents the x line, which is from here to this point, and that's 40 millimeter. And once I cut this, I actually came straight to what? The reference line. So which means it doesn't require any distance to get to the reference line. So I will simply have 40 divided by 2. So that gives me the central distance of the second segment about the reference line, simply 40 all over 2. And this is simply what? 20 millimeter. Okay, simply 20. So that's how you obtain central distance. After obtaining central distance x, we still need to find central distance y. So we find central distance y. Central distance y. Okay. So the same thing, now we are bisecting the y direction and not the x direction. So since here is x, I've said for the first shape, this is the x direction. Meanwhile, the y direction is simply what? This height is the y direction for the first shape. This height is the y direction, and this height is given to us as 50 millimeter. So I will simply cut through what? 50 millimeter. So I'll simply have 50 divided by 2. So for the first shape, I have 50 divided by 2. But it doesn't end there. I said you must always send what? The central distance down to the reference line. The reference line is simply what? This line ED, or simply XX. Okay, so if I send this down to the reference line, I have to pass through again this height from this point to get to the reference line. I still have to pass from this height to get to this point. And this height to this point is simply what? 10 millimeter. So simply add that same 10 millimeter to what? This 50 millimeter that you've cut through. So remember, I cut through this 50 millimeter, which means from here to this point now remains 25. So I have to still move from here to this point to get to the reference line, which means I'm adding this distance 10 meters towards that. That gives me the central distance in the y-axis. Okay, for the first shape. So I simply have plus 10, and this is simply equal to 50 divided by 2 is 25. 25 plus 10 is simply 35 millimeter. Okay, so I find the second centroid, and I say for the second shape, the y-axis is simply what? This height. So if I bisect this height into 2, I'm simply cutting what? The given height into 2, which is what? 10 millimeters divided by 2. Then I take it down towards central distance. Notice that from this point to this point is still 10 divided by 2. From here to this point is 10 divided by 2. So this becomes the centroidal distance about the reference line. So which means it didn't pass through any other height to get to the reference line. So it's simply 10 divided by 2. So I have that to be 10 divided by 2. And that is simply equal to 5 millimeter. Now, after obtaining the centroidal distance, the next thing to do is simply obtain the product of the areas of each of the segments towards the centroidal distance. So I will simply have here, let me say I have A times X. A times X simply means the area of the first shape times, simply means the area of the first shape times the centroidal distance in the X direction. Also, area of the second shape times central distance in the X direction. So obtain those two multiple. So that's AX, area times what? Central distance in the X. And here, area here is 1000. I simply have 1000 multiplied by central distance here is 20, 20. And this will simply give me equal to, okay, that's simply 20,000. Okay, that's central distance A F. The area, that is simply the area of the centroid. That is simply the area of the shape, the first shape, and what? The centroidal distance. Next, also obtain the area of the first shape or the second shape. Next, also obtain the area of the second shape and the centroidal distance about the x direction. So we simply have 400 times 20. So we have 400 times 20, and that will simply give us, okay, that will simply give us 8 8,000. So we simply have that to be 8,000. Okay, we'll have that to be 8,000. All right, so that becomes the area, the product of the area of each of the segments about the centroidal distances. Now, after obtaining this, you obtain summation. You sum this area, you sum these products up. Okay, after obtaining this, you sum these products up. So simply sum them up. Summation AX simply gives you, add the values. You have 20,000 here plus 8,000. That simply gives us 28,000. So you have this. Okay, that gives us 28,000. Next is to find the product of the area of each of the segments and the central distance in the y-axis. And central distance in the y-axis for this first shape, we have 25. Okay, so we have the area, which is 1000 multiplying by 25. So 1000 multiplied by 25. So that simply gives us 25,000. Okay, that simply gives us 25,000. Next is also the area of the second segment, which is 400 multiplying by what? The central distance in the y-axis for the second segment. Here is 5. So we simply have 400 multiplied by 5. Okay, so this simply gives us 2,000. Okay, so we have this 2000. All right, so after obtaining this multiple, you now sum them up. We simply have summation of area times y, and that's simply equal to. So we have there 25,000 plus 2,000. That simply gives us 27,000. Okay, so we have this now. At this point, the central distance. Okay, so at this point now, the centroid is simply giving us. Okay, centroid. Now we have two centroids. It's simply for the first centroid we have and x bar is simply giving us summation of area times the central distance x all over summation of the area, and this is now equal to summation ax. We obtain the value as simply was 28,000 here. So this is simply 28,000. Okay, divides through by what summation of the area, and summation of area gave us 1,400. 1,400. So this is now equal to 28,000 divides 1,400 gives us the centroid in the x direction. So let's get that and see. Okay, so 28,000 divides 1,400 simply gives us 20. So this is actually 20 millimeter. So this becomes the centroid distance in the x-axis. Next centroid is centroid in the y. So we simply have centroid in the y, still the same formula. Okay, but simply now summation of area times central distance in the y all over summation of what the area, and this is now equal to the sum of the area and y, the sum of the product of the area and y simply gave us 27,000. So we simply have 27,000 divided by summation of area, which is meant 1,400. So we are going to obtain this to be 27,000 divides 1,400. Okay, so that simply gives us 19.29 millimeter. Okay, so this becomes centroid in the y-axis. All right, guys, so that's how you're able to determine centroids of a given what composite section. I hope you find this video interesting. Please, if you do, I would like to hear your thoughts in the comment section. Okay, if you're new to the channel, please don't forget to hit the subscribe button, and of course invite your friends for more subscribers on this channel. I will see you in the next video with more problems on centroids of composite section. Thanks, guys, and cheers.